Hello everyone, welcome back to IIPD, and in this video we are going to see how to configure the MicroLogix ML1400 as a Modbus TCP server. Okay, so in the previous video what we did, we had the ML1400 and we had a Schneider PLC. So in this, the Schneider PLC acted as a server and the ML1400 acted as the client. So this was acting as master to send the data and receive the data. Now the ML1400 is going to become the server and we are going to use Modscan application to find to see whether the MicroLogix 1400 can work as a server. Okay, it's very simple, similar to what we have done for the Modbus. It's very simple. Okay, let's open the software. So let's RSLogix English 500. So here let's create a new project, file new, let it be, so let's say 1400 series B. So same things you have to do, the channel configuration and everything. So you have to disable boot P, enable Modbus TCP and set up the IP address 192.168.0.4. Okay, so the subnet will be 255.255.255. Apply it. Okay, then what you have to do, you have to go to the channel on Modbus settings. So here this is how we will configure the Modbus TCP server configuration. Okay, so you can see here you have some options here. So you have the option to create coils, you have the option to create contacts, you have the option to create holding registers, input registers, that is the register which cannot be changed, and holding registers in which data can be read and written. Okay, so we are going to use this. So for example, now I will show you how to create it for all the four, but you can create any one whichever you want. Okay, so for example, let's say I have coil 0. So you have all data types, we have the data files from 0 to 8. So the coil, I want it to be data file 9, the contact should be data 10, file 10, 11 and 12. Okay, so after that, and I will give apply. So when you give apply, it will ask what is the size in words, what is the size you want in words and what type of data type you want. So what we are going to create, we are going to create for the coils and the contacts as binary elements. So let's say I want 7 binary elements for coil, another 7 binary elements for the contacts, and let's say I want 100 Modbus input registers as integers and 100 input registers as integer for holding registers. Okay, and give S and give OK. Now you can see on the left side coil, contact, input and output. So you can see if you go into the coil, it is all binary elements, it's all binary with 16-bit in each. Similarly, if you go into the input register or the holding register, these are all integer elements. Okay, integer elements with the total array of 100 elements. You can see 10 into 3, 6, 9 and 10, right? So what we are going to do, we are going to try to read these holding registers into the software. So this is very simple. So you just download it. You don't need to do any program for this. You download this. Yes. It's done. So now if you go inside here, so the program is basically empty. We don't have to worry about that. Okay. Then what you have to do is we have to open the Modscan app. So I have the Modscan app already opened here. So Modscan app is already open. So here what I'm going to do, I'm going to set up the connection settings. So here go to setup, connection, connect. It will ask to what IP you want to connect. So you just connect to the PLC you have. So 192.168.0.4 and that's it, and give OK. Then here you have to say which register you are trying to read. So you can read coils, you can read input status, you can also read holding registers. Holding register means the addresses will be 4 and input register will be, the address will be 3. So I want to read holding registers and I want to start the address from 001. That means 4001. It is starting from 4001. So in the holding register that we created, you see this 0 is the 1 here. It goes up to 9, okay, so up to 10, yeah, then it goes on like that. So let's say if I change the value in the PLC, for example, let's say 50, you can see once again, so holding registers started, okay, give me a second, just okay. Okay, so the problem is with the Modscan, it's not with the PLC. So its demo got expired. So let me close it and let me open the Modscan again, because I'm using the demo version of Modscan. So downloads, this is the Modscan file, close it, and I'm just running modscan.exe. So let's say okay. So okay, so it is the Modscan issue, not the PLC's issue. So okay, that's it. So now you open this here, so you can see here data uninitialized. So let's say I will go to connection, connect. So same IP, give OK, and here you change the coil status to holding registers, and see, you can see it immediately changed to 50. So if I change to 1000 here, you can see it changed to 1000. So similarly, if I go to maybe N9, you can see, okay, let's say 55 here, you can see the data changed to 55 here. So similarly, I can also change the value. So address 20 node. So I'm saying this is 20, means it will be around this one. So let's say I'm giving the value 1555. So update, you can see it is updating in the PLC from the Modscan. So if I am writing from 4000, 400, 40100, 401, okay, let's say 400090. So it will update here as, okay, let's say I want 4568. So 4589 update. You can see it updated as 4589. So now our MicroLogix 1400 PLC is working as a Modbus slave or a Modbus server. Okay, so in 485 it will be a slave, but in Modbus TCP this is now acting as a server. So and another way in which you can find this, or you can say to check whether it is working properly or not, is using the KEP server. Okay, so if you have the demo version of the KEP server, it is more than enough. We can use the KEP server to read and write the data as well. So let's do a small KEP server configuration and see how it is working. So I am waiting for the KEP server to open. Yeah, it's opening. So let's say I want to create a new channel. So this is could be your BMS server, it could be another PLC for your sake, maybe another MicroLogix 1400, or even it could be even a S7 1200 PLC in TA portal. It could be anything. So let's say a Modbus Mod TCP channel. So create it, and the driver will be Modbus FJHIJ. So Modbus TCP Ethernet. Next. So default adapter I will set it as the 0. The reason being that is because we need the PLC's address setup. Next, finish. Now let's say D1, sorry, let's say ML 1400. Next, Modbus model is Modbus. Next, so IP address of the device will be 192.168.0.4. Our PLC's IP address. Next. So nothing much to change here. Make sure the port number is always 502, that is the Modbus port. Next, and block size when reading data frame. Yeah, maximum you can read up to internal 32, holding 32. You can even put this as 100 because we have 100 registers here. Next, finish. So now we can add, okay, we can add a tag. So let's say I want the minimum as 10. So I want to read this address. Okay, let's say I say 1, and the address will be 40001. Done. So it is a word level address, read or write. I'm applying it, and I'm giving okay. That's it. That's more than enough. Okay, now let's do a small checking. Let's go to the OPC client and check whether it is running up. So 1400, you can see the value is already showing 1000. So if I change here as 500, so it will update in a few seconds to 500 there. Yeah, it's an OPC server, so it can be given to any SCADA package. Similarly, you can also change the value from here. You will be able to write the value. So right click, asynchronous write. Let's say I want to write 1 2 3 4, apply and OK. So it became 1 2 3 4. Asynchronous write. So I want like 0 0 0 0, apply, it became 0. So I gave 520, apply 520. So if I change here, for example, I am changing here to 785, enter, it changed to 785 here. So now for sure the ML1400 is working as a Modbus TCP server, and this is how you can configure Modbus TCP server. So this concludes the session on Modbus TCP on Allen Bradley PLCs. Thank you.